Hello. Hello. Okay. So online, can you hear me? Hello. Drop me a line of message if you can hear me. Okay, thank you. All right. Well then, good morning. Well, since last week we have quite a long lectures, and you also have to take home the activities to do by yourself. So I decided to switch the schedule a little bit. And let's say this week we do something a little bit fun and you can enjoy it. Uh-huh. Uh-huh. So today lecture would not be that long. Uh-huh. And you kind of have fun with the activities in general. Okay. Uh, so the idea for today is physical securities. It's physical securities. And in fact, I first make this activity like almost 10 years ago. And uh, it's among the first activity that I create for security class. I mean, I have to conduct a workshop to let people understand security in general, but also learn something. Mhm. So I make these activities. It's kind of fun if you ask me, and most people say it's fun and it's also informative. So let's see if you can learn something from this class today. All right. I call the class, I call my workshop Defense Against Dark Arts. And for those of you who are big fan of Harry Potter, maybe you familiar with the name, but if I'm not sure whether you are familiar with Harry Potter or not. But kids in my age, well, not that kids, right? I was in college back then, but we kind of enjoy Harry Potter. Mhm. You know Harry Potter? You know? Okay. All right. Uh, Again, there are lots of things to say about physical activities, but in this activity, I focus on Trojan horses or backdoor or code injection, just these three main ideas of physical securities. Mm. So here's the idea. Here's the idea. I I say if someone got physical access to your computer system long enough, he got everything. Mhm. If you allow someone to sit in front of your computer, in front of your server, whatever, if that's long enough, he can do whatever. He got everything. He can clone the hard drive. He can uh, log into your hard drive, change the password, whatever. He can do anything. All right. So physical access is not good. It's not good. And my idea is that, well, what is the best way to let you understand physical activities, physical securities? So maybe let you try something. Maybe let you try something. And there's also another idea. If you know what can the bad guy do with your computer, or what can the bad person, sorry, what do the bad person thinks? Mhm. Maybe you can better protect yourself. Uh-huh. For example, if you think that, oh, somebody may poison my water, so there are certain things that I should do to protect my water, something like that. So if you know that, oh, maybe if that guy can do this to my computer, maybe I should behave differently. That's the idea. Mhm. So again, just think like a bad guy, think like a bad guy, My hope is that if you understand the bad guy, you can protect yourself. But again, not that I want you to be a bad guy. Just think like a bad guy. So, ครับครับใช่ครับใช่ครับอยู่ในคณะวิศวะใช่ครับตรงถนนพญาไทใช่ครับอ่ามาฝากไว้ที่ห้องธุรการชั้น17ตึกวิศวกรรม4นะฮะครับชั้นครับตึกวิศวะตึก 4คณะวิศวกรรมศาสตร์ครับครับขอบคุณครับ Okay, sorry, the call from messenger he has to deliver me a packet. All right, so think like a bad guy. See what the bad guy can do with your system. Mhm. All right, that way you can better protect yourself. And that's actually the practice that I always do. Like, I think, okay, if the bad guy can get into this room, what can he or she do? Once I think in that hat, in that thinking hat, and I say, okay, how about if I have to protect or secure this class, this room, what should I do? That's the general idea of this class. And even in Harry Potter, and they got these professors who basically teach defend against the dark arts, and the idea again, learn how to defend yourself, not to learn the dark art. Just think like a bad wizard. All right. But a little bit about this Harry Potter things. If my memory serves, they change the professor for this class in Harry Potter every semester, right? Mhm. Someone would die, someone would quit in Harry Potter. But okay, that's not the case for us anyway. All right. So to make you think like a bad guy, I come up with few scenarios that we will try to do together in class. But before that, what is physical securities? Physical mean real person, right? Physical security means what if real person can get physical access to your system? Most of the time when we study security, we will say, oh, bad guy try to get through the internet, through the network, to the system, to get to the system. But physical security means bad guy sit in front of your system. Bad guy get into the server room. Bad guy can install something to your computer. That's physical security. And it can be anything like keyloggers, device cloning, spyware, malware, those sorts of things. And in fact, we also have something like this. Let me quickly show you the pictures. This is physical Krerk. From the look at it, it's just power outlet, right? Looks like power. But in fact, this one is a hacking device. Let's say you buy this power, you put it in your server room, you connect your network to this outlet to protect the server, to do the server protection. You plug computer in. What happened is that bad guys just get behind the building, connect Wi-Fi to this box and they get access to your computer. That's one case of physical device that you should not bring to your system. Anyway, I leave it to you to lead it by yourself, but this one is funding by, they say, US government to help people hack, to help the government officer get into some server system. Okay, the fun part begin. Let's try this. Let's say now we are in maybe library. You see your friend sitting in library, doing assignment, do homework, whatever. Suddenly, he quickly run to toilet and leave his computer on. Right? Again, you see your friend sitting on the table using his computer. Suddenly, he stand up and quickly run to toilet. His computer is still on. Everything is on. Now, assuming that you want to hack your friend, you want to get his password, but you got maybe a few minutes before he come back. Okay, your friend is now go somewhere else. You've got a few minutes in front of his computer. You want to get his username and password. What can you do so that when your friend come back and log in, maybe to a web application, maybe to Ph.D, to my website, and you get his password? What? That one possibility, yes. You can set a keylogger. But that means you have to install something or physically put something between his keyboard and his computer, right? But if it is a laptop computer, that would not make sense anyway. All right. So these scenarios, we will try to do JavaScript injection. Inject something to his browser so that when he log in using this browser, you will get his password. Okay, all right, let's me go into the details a little bit. You know that your friend have to log in to my class, to the class DD. To log into class DD, usually he would go to Shula SSO, type in his username and password. You happen to see, oh, he's now at Shula SSO, but not logging in. Assuming that when he come back, he will log in with Shula SSO. Can you inject something to his browser so that when he come back and logging in, you will get his password? Okay. Let me give you a few hints and I let you try for a few minutes. And I give you one possible solution to that. Okay, give it a try. Let me organize my screen a little bit so see how it works. Okay. This is, well, normally we would not run into this mode, right? It doesn't make sense, but just for demonstration. Okay. So Here on the left-hand side, it is should I ISO login screen. Mhm. If you quickly turn on the developer modes, you should see consoles on the right-hand side. Uh-huh. And in fact, you can inject something to the console on the right-hand side. Okay, let me give you a quick example. Let's say somebody type in username, make it ABC now. Uh-huh. If you inspect this web page, you may learn that, oh, this is input box with ID basic username. Uh-huh. So technically speaking, you can write a JavaScript, put the ID, and you can get the value, right? It's just a DOM, document object model, on this web page. And you can write JavaScript to access the DOM. Uh-huh. So you can quickly type in JavaScript here so that when your friend come back and try to log in, rather than logging in, I want you to show this alert dialog saying this is your username and password. But my point, inject JavaScript to this browser so that when your friend come back and try to log in, rather than logging in, you simply show a dialog and alert dialog saying this is the username and password that you just type in. Got my point? Okay, I give you maybe 15 minutes to try, and I show you how to do it. Okay, let's try it together. Mhm. Think about it. Do it in a way that your friends have no idea whether you inject something. But again, just for demonstration for the moment, you can alert this. Okay, I'm gonna pause the recording and resume later so the video will not be that long. Okay. We got one person that made it work. You got it work. How about others? Anybody else that got it to work? Online, anybody make it? Anybody got it? Yes. You got it? Yes. Let me see.ครับครับครับผมครับครับยินยอมครับ Okay. Um, let me show you one possible scenarios. Okay. Again, there are several ways to do this. Okay. There are several ways to do it. I show you how to make it work. Just one possible scenario. Okay. Uh-huh. Again, if you want to inject something, you have to learn about the page that you are working on. So I would take a few minutes to learn, okay, we got an input, basic username with ID basic username. Maybe I can use this ID to get this element, okay? Same things, I want the password, so I can inspect and see, oh, this also got ID basic password. Maybe I can use ID, okay? Or you can use other methods to get to it, like somebody may try to get element by class name. So you have to capture the class name and use it to get to this element. That's also possible. Or you can do simple traversal, like some browser allow you to do this. You can try document.fonts, zeros.children, zero, something like that. That's also works on typo. That also works. So it depends. There are several ways to get to that element. But in this case, use the ID. Pretty simple, straightforward. So we know the ID, basic password. And some browser even got a way for you to capture it. Attribute, copy, attribute value, basic password, like this. Okay. And our scenario say we want to capture the events that when somebody clicks submit to this form, we want it to run something. So again, the ID of this form is basic. Okay. So to make it simple, if you want to get to the username, you just use document get element by ID. And the ID is basic username. This should give you the value of the username. And if you want to get to the password, you can use and try basic password. dot value when you get the password, right? Now, if you want to get to the form, you can do similar things, document.get element by ID, and the name of the form is basic. That would give you the whole form. Okay, now I got the building block of things that I want for these scenarios. I got the form, I got the two fields, two input fields with username and password. So I make a script. I make a script. The script is like this. Okay, I get the username, I get the password, I use it to construct a string. So if you simply run this, you just get something like this. Oh, okay. It should be value. So this is thing that I want to learn. All right. So that's not all, right? Because we say we want to capture the event. So I say I add event listener, add the submit event to this form. And when you click submit on this form, just call this function. So I prevent the default event and run our code. So with this, I just copy them all, put it here. Now, when somebody try to log in, you will see this. Again, this is just one possible scenarios. Okay. Now let me challenge you a little bit, make it a little harder. Now you got the idea how to make things work. Okay. Now what if I want that when your friend log in, it send the username and password somewhere that you can grab the information. And your friend have no idea what happened. Right? This is simple, right? You just pop up something. In real attack, we would not do this.
Maybe you have to send it on the different server, like on the computer or something.
Right. Yes, that's the idea. You got it. Yes. But give me a demonstration. How does it work? Give it a try. Again, 5 more minutes. You can do it. Okay. You got the idea. Yes. Okay, got the idea? Got it work? Well, this yeah, I would say if you know how to do JavaScript or web programming, you should got the idea. But okay, let me again show you one possible scenarios again. Okay, let's say I got an access to a web server. Okay, this is belong to the department. Okay. So, all right. Uh, Again, this is just one possibility. Okay. So rather than alert the username and password, this is what we can do. We can maybe use an image link to send this to kind of call an image for our web server and pass username and password within that URL. That's one possibility. That's even though we have no image at all. Okay, so it's like this. I make a string, but rather than this pop-up string, I say I create. Okay, so this is an image tag that would try to call an image from my web server. And within the URL, I pass the username and password as a path string, okay, like this. All right. Now, we somehow just have to get this to add to this web page so that it would kind of request this for me. Okay, how? So I quickly take a look at this and I see, oh, we got something down here. Maybe I can just add image tag down here and they would not notice. So we got a tag name address. Maybe I add image to this address, right? Again, just one possibility. Okay, there are several ways to do this. So what will happen if somebody try to submit this one? Then we inject this to our browser. What happened is that when somebody try to submit it, it would try to query for image. It's oops, maybe I typed something wrong. Sorry. I forgot the dot. So okay, try again. Document dot get element. Okay. Forgot an S. Sorry. Yeah, forgot an S. See? Maybe you don't see. But here you see a small image here, but on the log, on the log of my web page, Oh, here. See this? Okay. Okay, let's try something different. See? Now your friend log in. I'm just sitting, monitor the log files of my web server. I see his username and password. Again, just one possible scenarios. Okay. There are several possibilities. And why image tag? Because image tag would try to query an image. And I can use it to bypass the cross-site scripting protections, those sorts of things. So by put the URL in, I can bypass protection of the browser. All right. So this is one possible scenarios. Somebody leave his computer on, even though he logged out from the web page, run away. When he come back and he say, okay, I want to continue working. So I just type in username and password, but oh no. Even though I can log in, but it sent my username and password to somebody else. Not a good idea, okay? But since this is just JavaScript injection, if you just refresh the page, done. It clear everything, right? But bad idea is that you leave it on. Somebody inject the code and they put it back to normal condition. You have no idea what happens, right? You see nothing. It looked normal to me, right? You type username and password, and wait, somebody just got it. So what is the moral of this story? The leave it on and attendant, maybe? Okay, any question about this? I see that some of you want to take picture of this code. Oh, disconnect now. Okay, if you want to take pictures of this, that's up to you. And I just want to let you know that I see somebody make this happen with Facebook login page or Google login page. I would challenge that if you look around, maybe somebody already makes script like this, that you can just take it. Mhm. Mhm. Okay. Anyway, this is just one example, one scenario that somebody injects JavaScript to your browser. Somebody injects JavaScript to your browser. You have no idea what happens. Okay. You log in, you try to do normal function, but wait, bad guy just got the information that they want. Okay, give it a try. Even with Google logins, Facebook logins, it works. It just works. Maybe more complex, but just work. Okay, may I skip this to the next activity? A little more challenge. Okay. All right. That's for the first scenario. Let's see what time it is. Okay. Again, simple JavaScript injection. Okay. I give you already tried it and somebody got it to work. Somebody who may not familiar with JavaScript may find it a little difficult. But this is what hackers can do in minutes. I would say in few seconds. Okay. I told you this. Give it a try with Gmail, with Facebook. Okay. Let's try the second scenario. Actually, this one not me, somebody else did that. Reverse engineer from Microsoft SQL Slammer worlds. This is how SQL Slammer put Trojan horses into your computer. All right. The real SQL Slammer is a little complex. There are several steps that the SQL Slammer try to get in and eventually put the Trojan horse in. So I just use this netcat. Well, what is netcat? Netcat originally designed to do reverse shell or to do remote debugging. Like you install netcat on another computer and you can just remote debug the software on that computer. That's the original idea of netcat that people have used it for years. But bad guys also learned that, well, we can use netcat as a trapdoor or Trojan horse that allow the bad guy to sneak back into that computer later. So the scenario is like this. Somebody may fool you to install a software, or again, your friend may got a few minutes, bad guy may got a few minutes in front of your computer. What is the best thing to do? Install something that I can get back to your computer later. Right? Because if I got just few minutes, few seconds, maybe I can quickly I mean, the scenario one may not be enough because scenario one means you have to explicitly log in and navigate it. But what if you didn't log in? I get nothing, right? So why don't we put something into that computer? That way, even though you go away, when you turn your computer on again, I can get back in. That's basically the idea of Trojan horse or backdoor or trapdoor or whatever you want to call it. Put something in so that I can get back in later. And that's something to put in. In this case, we will use netcat. You can install netcat on your computer. Just download it, install it, or if you run Linux, you can just install it from the package management. Okay, so you will need some time to install the netcat on your computer. This one works on almost any platform. If you use Mac, use Homebrew. If you use Windows, you download it. If you use Linux, just install from the package management. And what I want you to do, I want to make a group of 2 persons, if possible. A group of 2 persons. Okay? Get together with your friend, and we will do a role play, assuming that one person would take a role as a victim, another person would take a role as an attacker. You can switch later, okay, just to get the idea. Okay, one victim, one attackers. You may want to join the same Wi-Fi network. I learned that sometimes the university Wi-Fi network, the Shura Wi-Fi, sometimes they do a little protection that you cannot connect directly between two computers on the same network. They protect that. So maybe you can just use your mobile hotspot, turn it on, and connect to the same network. Easier, okay? We will try first make an attacker as a netcat in listen mode, and the victim would try to connect to attackers. Okay, this is how it works. We got two computer names in this screen. Okay. First person, in this case, is a Linux machine, the victim. Second person, hackers. So this is step number one. Hacker start netcat in listen mode on port number 60,000. Basically, I start netcat and leave it open like that. Then I get to the victim machine. I start netcat, execute the shell command, send it to the IP of the hackers on this port. So it's like hacker now got shell access to the victim machine, but using keyboard and screen from his computer. And that's what netcat do. Netcat basically redirect keyboard and send that in, send that out, keyboard and screen, the terminal screen, to another computer. So we redirect the keyboard input and the terminal screen of the bash command to the hacker. Okay, and hacker basically got access to victim computer and can do anything as if he sit in front of that computer. So that's one reason that netcat usually used as a base for Trojan horses, because it gives you a way to redirect something to the hacker machine. Okay, give it a try so you understand what I'm trying to say here. Again, I pause the recording so the video would not be too long. All right. I see some of you have already got it work, so let me give you a walkthrough. Okay, let me give you a walkthrough demonstration for those of you who may not get it to work yet. So this is how it works. I got two screens here. I got two screens here. On the top, sorry. On the top, I would make it attacker. Okay, this would be the attacker, and on the bottom, I would make it a victim. Okay, so it's two different machines, and just remote connect to another machine. Okay, so let's say I am an attacker, so I start netcat in listen mode in this case. Why? Because I know public IP address of my computer machine. So I start it in listen mode, just like that. Okay. Whenever I got a chance to the victim machine, I just run this command. Hey, run the shell command, connect it to my machine, because I know the IP of my machine. So I put the IP of my machine, in this case, it's a host name, right? And connect to the port 60,000, which I specified up to 60,000. So I connect it back. Right? Now, on the attacker machine, it's like I'm sitting in front of the victim machine. So I can just do what I want. So let's try something simple, okay? I create a file on desktop so you can see on my desktop. Yes. See? Right. So bad guy now can do whatever as if the bad guy is now in front of my computer machine. Use the shell on my machine. You can also reverse that. Right? Reverse that. Reverse that in the sense that rather than start the victim machine, rather than start the attacker machine in listen mode, you can start the victim machine in listen mode. But again, this would not make sense because victim machine in this case is my machine here, and it's got on the dynamic IP address. It moved. So there is no way for other hosts to connect to this machine directly because we kind of pass through the NAT, the network address translation, and so on. So in this kind of attacks, we need maybe one public IP address. In this case, it is the attackers that got the public IP address. So we send the shell to attackers. Got my point? And since netcat basically redirect whatever, redirect standard in and standard out of whatever program, in this case, I send the shell. It can be anything. You can send other program. Okay. Well, okay, let's just for the demonstration again. So rather than I send the shell, the bash shell, maybe I send Python. Oops. Yeah. Maybe it's not working. That doesn't make sense anyway. Okay, any question about this? So anybody got it to work or still have trouble? I see this group got it to work. You got it to work? Maybe not. Yeah, you got it? No? Okay, maybe I help you a little bit and all right. I see that some of you got it to work, but some of you may not got it to work due to the security of your computer. Like we got the case that a Windows machine detect the netcat installation and try to delete the netcat because it was abused. The software netcat has been abused in several cases. So sometimes antivirus on your computer try to delete netcat. That's one possibility. Okay, so you may have to turn it off if you want to try this. Just that most of the time, normal people will not install netcat just like that. That's why sometimes your antivirus would try to delete it. Okay, and we got a case that the netcat version on Mac sometimes prevent that. So a little tricky, right? But in reality, bad guy use something like this to set a trapdoor on your computer to find a way to get back in. So sometimes you think that you just download free game and install it on your computer, but eventually you just install a trapdoor for the bad guy. So think about it when you want to install some software on your computer, or sometimes you have to monitor the network activity on your computer. Like if you use the Linux machine, they got a command that you can monitor the network like netstat, show all kind of listening or connection from my computer to others. Right, the command netstat. So you might want to run that from time to time to see, oh, we got some kind of unusual connection. Maybe it's the bad guy sneak back in. All right, and that's one possibility. So, okay, you may try that later at home or set up a group with your friends and give it a try. There are several scenarios. Think about it, try it on yourself. And also, you can reverse, right? You can start victim in listen mode. Basically, you just change the victim to -L and -P. And whenever hacker want to connect to victim, just netcat and connect to the IP address of the victim and the port of the victim. Either way. But this would not work when victim is in behind a firewall. So victim must got an public IP if you reverse that. In this case, in this example, the hacker got a public IP. So we type the public IP of the hacker. All right. Think about it in reality. This can be auto start software. Whenever you start your computer, it connects to somebody else. Connect your computer to the bad guy, maybe. All right. So think about it. Anyway, let me wrap up a little bit. Again, with physical access, if bad guy can get in front of your computer long enough, he got everything. I just give you two possible scenarios. In real attack, bad guy may clone your hard drive, do reverse engineer of the data or whatever. Right? This is just simple attack that bad guy can do in short period of time, just like that. So here's the activity for today. Simple as that. I want you to write a short essay, outline scenario that can happen if a bad guy can get in front of your computer. What can the bad guy do, even though he got few minutes on your computer? Right, just one short essay, just like that. And just give you a quick start. What have we learned so far? You should not leave your computer unattended. If you have to, at least lock the screen. Or find a way that you can secure your computer. I don't know, password, whatever. Okay, and always check for unusual activities on your computer. Check some privacy, check the settings, security settings. And some computer, they got like, in this case, my computer got this little privacy protection where you can just switch off the webcam like that. And you may know that some IT guy like Mark Zuckerberg, the CEO of Facebook, he got posted on his camera to protect his privacy. Right, so you don't want to leave it on, and I just turn it on so that I can record the video for the class, but most of the time I turn it off like this. Okay. All right. And I think that's it for today's class, just to let you have fun and think about physical securities. Before you go home, I will post on the Facebook, but next week we will do auditing. Next week, I will give you some kind of access log from field servers. And we will find bad guys from that log. Okay, you will play detective things. But to do that, we need a little tool. So next week, I want you to prepare this. I want you to install Sprung. Okay. Install Sprung. I post on the Facebook how to install it. You have to install Sprung on your computer. And in class, I give you access logs from field web servers. And we will find bad guy, try to find bad guy together in the class. Okay, so install Sprung. For that, we don't have to use eyeballs to look to thousands or million lines of traffic logs. We use Sprung to extract information that we want to see. Just a little tools that make your life easier. Okay, I post on the Facebook how to install, how to download it. You can use Docker if you want. If you don't want to physically install it, just use Docker image, just like that. Okay, any question about today's class and activities? Are we having fun? Having good time in the class so far? Okay, I intentionally make it short, compensate for a very long lecture last week. All right, so I call it a day. I leave it now. You go enjoy. Don't forget to install Sprung. Thank you for joining. See you next week.
Thank you.